So this class we are going to discuss about the nuclear fission reactions. So before entering into this nuclear fission reaction, we should know the popular scientist named Otto Hahn, Fritz Strassmann, Enrico Fermi. These three are very popular scientists. Otto Hahn, German Nobel Prize winner, famous for discovery of the nuclear fission reactions. He was a very first person in discovering the nuclear fission reaction. He got the Nobel Prize. Fritz Strassmann identified the barium there is after bombarding the uranium with neutrons. Later on we will see the equation. When uranium is bombarded with the thermal neutrons, it is split into barium and krypton. He identified the barium. So he also became a reputed scientist for nuclear fission. Enrico Fermi is another Nobel Prize winner and famous for creating the world's first nuclear chain reaction. So the fission reaction keeps on going without any control. So in the chain fashion, that also we will be going to see in the incoming slides. This is called explored by the Enrico Fermi. So these three people are very, very important when we talk about the nuclear fission reaction. So what is a fission? Fission is another word for splitting. So literally it is called splitting. So it means division or splitting. It means a division of splitting into two or more parts. Means the splitting of the parent nuclei into two daughter nuclei. In general, if a heavy particles or object split into two or more parts or fragment is called fission. So it is called fission. So it is called so what is the liquid drop model for the fission? So how the fission happens? Some liquid drop model they are getting. So generally the nucleus is considered as a spherical particles. Upon during the course of the fissions, it is converted into ellipse-like shape. Then it is started to elongate. Then it is split into the stage of the splitting. It is converted into another sphere-like part, just like your sphere-like part. Then finally it is divided into two parts. This is called liquid drop. How the liquid drop split into two? So elongation. Then the stage of the splitting, finally these two are split into these two one. When a nucleus is split into several smaller fragments, usually in 235 fissions, these fragments are called a fission product, are about equal to half of the original mass. So later on we will be seeing about the when we come to know the balancing of the nuclear reactions, we will come to know how the mass numbers or charge numbers are balanced. 2 or 3 neutrons sometimes also emitted. The sum of the masses of this fragment less than the original mass. The missing mass has been converted into energy according to Einstein famous E is equal to mq square. So this tells about the mode of this called the nature of the nuclear fission reaction. Means during the course of the reaction, heavy nucleus split into two fragments. Sometimes neutrons or subatomic particles or atomic particles are also emitted. So just when we add the mass of all the parent nuclei, when we add the mass of the all fragmented or daughter nuclei, including the emitted particles like atomic, subatomic particles, that mass will be equal to the parent. That mass will be equal to the mass of the parent nuclei. If there is any mass difference between the parent and daughter nuclei, definitely it is converted into energy according to Einstein mass energy relationship. Fusion can occur when a nucleus of heavy atom captures neutron. The nucleus will capture the neutron, or it can happen simultaneously. There are two chances for the fission. One, sometimes it may occur naturally. Sometimes we can induce a fission by just bombarding the heavy nucleus with some some accelerating accelerating particle like neutron. So thereby, if we just make a bombardment of the heavy nucleus, it also leads to the fission reaction. But sometimes it is also, that is called induced fission. Sometimes what happens, the fission reaction occurs naturally. So see the diagram. This is called uranium 23592. When it is bombarded with the thermal neutrons, it's called neutrons having some kinetic energy. So how it gives the kinetic energy? It is accelerated. It is accelerated with some particle accelerator like cyclotron, synchrotron, like this. Automatically these particles get the energy. So that if we just make it to bombard with the energy on the heavy nucleus, so it started to create unstable or metastable nucleus. Finally, so the spherical becoming elongated spherical, this is called elliptical like shape. Create unstable excited nucleus. Finally, excited states are unstable. It is split into barium and krypton, these two nucleus, with the liberation of the three more atomic particles is nothing but your neutrons. So this diagram is represent the form of the equation. U23592 is called mass number, this is called atomic number, this is the neutrons bombarding particles split into barium and krypton. 19, 143, 36, 56. So fission of the single uranium means atoms creates a 3 neutron along with the splitting. This is called parent nuclei. These two are the daughter nuclei. So along with this two fragment, it also emits 3 neutrons. Means fission of the single uranium nucleus with slow moving neutrons creates 3 neutrons with the daughter nuclei barium and krypton. So neutrons, so further what happens, the emitted neutrons causes another fission by colliding with another U235 nucleus. Okay, so the neutron will not be ideal as such because it also gives energy. Yeah. So these energy, the neutrons collide with another U235 nucleus, thereby creating another fission, creates a 2 smaller nucleus and free neutrons. So this is the initial things, barium and krypton. The 3 neutrons are there. So all each one of these 3 neutrons, is the bombard means collide with another U235 nucleus. This is another U235 nucleus. This is another U235 nucleus. So this is like this. So initially automatically creates 3 more fission. Further it is split into barium and krypton. Again with for this one, these 3 neutrons happens. For this one is a barium and krypton, 3 neutrons happens. For this one is called barium and krypton, 3 neutrons also happens. So listen the point. So listen. So initially one fission creates a 3 neutrons. The 3 more fission creates a 3, 6, 9 neutrons. So this is called chain like fashions, keeps on going like this. So every one of these 3 neutrons induce means collide with another collide with another U235 nucleus, causing 3 more neutrons. It is also causing the 3 more neutrons liberation. It also causing the another fission giving barium and krypton and 3 more neutrons. So like that. So 1 become 3, 3 become 9. So like this 27 become 9 become a 27. So this is a 3 power 2, like the squaring fashion keeps on going. 3 power 1 which is equal to 3 power 2, which is 9 neutrons. 3 power 3 become 27 neutrons. 3 power 4 become 81 neutrons. Like that, each fission is accumulated with a large quantity of energy, along with the energy is also limited. So the fission causes barium and krypton daughter nucleus production, also 3 neutrons. Along with this one, plenty of energies are released. This energy is released due to the mass defective. That is according to Einstein mass energy relationship is equal to mg square. So this is called neutron. So this is called chain reaction steps in the nuclear fission. The U-235 nucleus capture the thermal neutrons. Capture results in the formation of U-236. That is, we saw in this one. And the excess of energy of this nucleus causes it to undergo a violent oscillation. Violent as this is a U-236 unstable nucleus is called violent oscillation. So violent oscillation undergoes the U-236 nucleus become highly elongated. The force of repulsion between the protons in these two halves of the dumbbell-shaped nucleus tends to increase the distortions. Thus, the nucleus split into two fragments, emitting the several neutrons in the process. Okay, fission can be used for good purpose or evil purpose. So this is called atomic bomb purpose. The atomic bomb works on the principle of nuclear fission reaction. We can use such a liberated energy for the nuclear power plant to produce the electricity. We can use the nuclear reaction. There are these two things of it. The fission process, a neutron travels with low speed towards the U-235 because we have to employ the thermal neutrons which possess the lower kinetic energy. That kinetic energy is gained by accelerated neutron with the particle accelerator like cyclotron and synchrotron. You might study in your physics classes. So listen the point, this keeps on coming. So like this 235, so 236. Now the uranium, so converted into 236 from being as it has captured the neutron captured. Then what happens? The forms is very unstable. It forms in the very unstable. It transforms to elongated shape for the short time. It forms elongated shape, not a spherical shape. So further elongated shape is there. Further it's called dumbbell shape, it means spherical elliptical shape. Then it's called elongated elliptical. Then finally converted into splitting. It's called barium krypton. So each one is converted along with the liberation of the 3 more neutrons. Then is split into 2 fission fragments, release the neutrons. This is called 2 fragments, 3 neutrons. So again, every one of these and also releases further. Every one of each one of these neutrons further causes splitting of the N235 nucleus as before, creating another barium and krypton, another 3 more neutrons. Like this keeps on chain is going. So this is what the process that you can imagine like this. So these further steps are like this explode here. Explode totally here. So this is a total steps. So thanks for your cooperation. Okay, thank you.